How's everybody doing today? Got some cold weather coming, 35 degrees coming up tonight, next couple of nights, so just went down and got some firewood. And today's video I'm going to show you my indoor boiler. Hi guys, we're in the boiler room. This is the boiler. It's made by Froling, which is a German company, and it's a gasification boiler. I'm going to show you the print, which this boiler was. It shows how the boiler interacts with the rest of the house and the rest of the system. Essentially, here's the wood boiler, and it has a circulating pump right here. That circulating pump comes on once the water jacket in the boiler reaches 150 degrees. And it'll circulate the water so that way you don't have uneven heating in the boiler jacket. What that is an emergency dump zone. If you lose power, this valve automatically opens. So that way if you have a fire going and you lose power and the air vents don't shut, the boiler won't overheat. It has a big enough emergency dump zone where it dissipates all the heat. That's inside the house. I'll show you that later. So at 150 degrees this pump turns on and it circulates right here through this area. The reason it does that is because this valve right here is like a thermostatic valve, just like your thermostat in your car. It will not open and allow any of the flow to go anywhere but back to the boiler below 150 degrees. Above 150 degrees, this opens it. Well, what it does is it shuts off number 1 and opens number 2. So that way flow from the boiler can now go over here down into this coil, which heats the storage tank. And then the cool water returns back through this valve and into the boiler to get reheated. So that's pretty much the boiler and how the storage tank works and how those two interact. Where it gets interesting is when you have a fire, you're charging the tank, and then the normal controls in the system, your thermostat up in the house, like this represents one of your zones, say maybe your kitchen or living room, dining room. One of those areas call for heat. What happens then is it opens up this zone valve and it turns on this circulator. Now if your fire is still burning and your water jacket's above 150 degrees, this circulator is still running. So you got hot water from the boiler now serving whatever demand is in the house. It'll go, instead of going back to the tank to charge it, flow is diverted through the zone valve, through this circulating pump, and out to your main header. And then if you have an individual pump for your zone, it pumps the hot water to your zone. Now the boiler's output's around 185 degrees. That's like an ideal baseboard water heat system. If you've got in-floor heating, it's going to be much lower temperature. I'm not going to go into that. So your heat goes out to your loop and it circulates. The interesting part about this system is after it goes through and gives off the heat, it comes back here. That's a check valve. It can't go back that way. It's forced to come down here. It comes to this zone valve, or not zone valve. This is a it's another thermostatic valve basically. For this valve, if the water coming back to this valve is above 165 degrees, it gets sent back this way. Back this way and back around for another ride until it's lost enough heat and it's below 165 degrees. Once it's below 165 degrees coming out of this zone, it comes again back to this valve. Below 165 degrees, it's going to divert it down this way and back to here. And this valve may mix it so that way you always have 150 degree hot water coming back to your boiler. That's the key part of this valve right here, is it's a minimum temperature protection to the boiler. You always have hot water coming back to the boiler at 150 degrees. That prevents creosote and corrosion in the boiler. So that's basically it in a nutshell. Make sure you're seeing this. Hopefully it comes out well. The other scenario, so that was the scenario of fire going in the boiler. A zone calls for heat. What happens in the controls. The other times the system calls for heat, you may not have a fire going in the boiler. In that case, your zone calls for heat. This pump turns on. This pump turns on. Your zone valve opens. And because this pump is not running at the boiler, no water goes back to the boiler. Water comes from your zone through this valve. It's less than 165 degrees. It comes down here. It goes to the tank. Goes into that heat exchanger. Gets heated back up. Comes back up this way through your zone valve. Back through that circulator. And out to your zone. So this heat exchanger in the tank works both ways. It heats the water in the storage tank, and it also removes the heat in the storage tank. And it does that because it has two check valves in the one line right there. I used all 1 1/4 inch copper tubing. The straight copper, even though it's expensive, is dwarfed by the cost of the fittings. Why did I do copper? It was recommended by the Boilermaker and everybody else I talked with. You can use PEX, I'm sure you can. I don't know what the upper temperature rating is of PEX, but copper doesn't lose its value. And in my opinion, it's a longer, better product, reliable product. So I did everything in copper. I'm getting ready to fire this boiler. I'll give you a quick rundown on the lighting process and demonstrate how easy it is to use. There are other gasification boilers that boast a pretty good efficiency rating. It's my opinion this is one of the best, top two. And the one thing that makes this, in my opinion, the best boiler is the user interface and how easy it is to use. When I purchased this boiler, one of the major factors was ease of use. I need something where my wife's not intimidated to come down here and light the boiler and heat the house. I also want something that's efficient and easy to use. It's primarily two things. Of course, budget's always in there, so everybody's budget's different. So, that being said, I'll load it, I'll start it, I'll show you how easy it is. I'm going to show you some of the controls, and we'll go from there. Okay guys, this is the control panel on the Froling FHG. This boiler's got 105,000, I believe, BTU per hour output. On the control panel, you'll see a couple of numbers. The ones on the left are the storage tank. You can see the upper tank temperature is 142 degrees. The lower temperature is 128. In the worst parts of winter, I try to recharge the storage tank when it hits about 150, 155. And that's primarily because your baseboard heaters, the emitters, it's a copper tube with aluminum foil fins on them. They really start to lose a lot of efficiency below 160 degrees. If it's 10 degrees below zero outside with a 5-mile-an-hour wind, 150 degrees is going to be about your bare minimum. If you've got in-floor heating, PEX, or in concrete or what have you, your lowest usable temperature in your storage tank is going to be much lower. In-floor heating is usually sending about, I think, around 110, 120 degrees out through your floor. So if you think about it, my max temperature is 180 in my storage tank, and I recharge it, let's say 140. That's an even 40 degrees. 40 degrees of differential temperature over 820 gallons. I could do the math and show you what that looks like in BTUs. And then let's say you use that over a 12-hour period. Now you know how many BTUs per hour my house would use. If you've got in-floor heating and you can draw this tank temperature down to 120, 110 degrees, you just picked up 30 more degrees of differential temperature over that same volume. You've basically doubled your heat storage. So for you guys that have in-floor heating and you're thinking about doing a boiler, definitely consider one with a storage tank. Doesn't have to be this boiler, but a gasification, what they call batch burn boilers, and you'd be surprised on how long you could actually go without reheating. All right, enough rambling. The number in the top right, AGT, average gas temperature. So there's a temperature element in the flue for the chimney. Can't really see it. Okay, that little brass plug right there, that's the temperature probe. There's also an O2 sensor, just like your car has, and it's measuring the residual oxygen, and it's adjusting the air dampers to meet whatever program criteria it needs for optimum burn. The lower temperature is your boiler jacket water temperature at 123 degrees. Interesting thing about this boiler is that little thing right there represents the storage tank, and it's telling me it's approximately half full of energy. Now the other unique thing about this boiler is it has the ability to calculate based on your storage tank size and what the temperatures are in the tank, how much wood you should load in this boiler. Of course, those numbers are based on the company makes a designed storage tank to complement this boiler. If you're using a storage tank other than what they sell, your numbers are just going to be an estimate. But really, it's like any other machine or wood stove for that matter. You kind of get the hang of reading the tank temperatures, looking at the weather, gauging how much wood you need to load in it for the day, and you can just look at the temperatures and know you don't really need that calculation to tell you how much wood. But it's on there, so it does help a little bit because it's pretty consistent day to day depending on the weather, how much you're going to load. If it's really cold outside and your house has got a high demand, you can get away with adding a little more wood into the stove because ultimately the house is going to take some of that heat during the recharging of your storage tank. So you can tend to put a little more wood in there. But you don't want to go too much because it'll put the machine into slumber mode, which is kind of like a smolder mode, so to speak. It's going to keep the wood burning, but it's going to choke the air off. You're just going to waste fuel. You can create creosote, but ideally your wood's dry, 20%-ish, 20-24%, and you're not going to see much creosote. So I haven't seen any with mine. So, but the other important part of this system is you got to have a Class A chimney. Let's move the camera. Okay. So up there is the stainless steel Class A chimney. I'm using a single wall up to that point, and then I've got 18 feet of Class A 6-inch chimney. It's insulated, triple wall, stainless steel. Because of this machine is so efficient, your exhaust gas temperatures are very low. And what creates draft is the temperature differential between what's inside the chimney and what's the outside temperature. So when you lower your temperature leaving the stove, you have less draft. And so in order to maintain the draft, you got to maintain the heat in that gas. Okay, so what I'd like to do is put a couple pieces in there, just on the edges, and then get a small piece and lay it across that nozzle, so that way nothing drops down and blocks the nozzle. But also something small and dry that will catch easy and burn away. And then from there, just fill it in with something a little bit bigger. Got to give it plenty of airspace. And what I like to use for starter material is paper egg cartons. Paper egg cartons, not quite like cardboard, but they hang around and burn. I like to crush them. Stick one in there, both sides of that nozzle. Probably only need one of them, but we eat enough eggs. I can't get rid of them fast enough, so. Put 2 of those in there and then load it up. Now, after we start the fire, you'll leave the lighting door open slightly, and you just watch for the gas temperature to climb up with the door cracked. I usually close the lighting door when the gas temperature reaches, I don't know, 210 degrees boiling. There's no rhyme or reason. It's just what I like to do when the boiler has a water jacket that's 150 degrees or thereabouts. You can shut the light. You can shut the boiler a lot sooner than if the boiler temperature was like 100 degrees or less, because it's gonna take a lot of heat out of that fire. The colder the water jacket is. So I'm pretty good right there. This is what I would call half load. It's really a little bit less than half. Something that is at the bottom of this plate right here, I consider a little less than half. The pin on the door, I consider that 3/4 full, and this would be full. So if it's telling me 14 kilograms of wood, to me that's like a half load. I probably got one too many in there. I don't want to put too much in there. I'd rather undershoot and have the tank charge only up to maybe 170 degrees instead of max 180 degrees and it go into slumber mode. Okay, so we're gonna light it. Okay, just turn the fan on. Now I use a simple torch just to light my fire in there. Gives me a nice little reach. And this can is just about due to be replaced. I think it's lasted probably 2 years. Okay. You see it pull that flame right down to that nozzle. There, let's get you in there. That's pretty much it. Then as the wood burns down, it just falls down on itself over that nozzle and keeps burning. Alright, we're going to close this lighting door some now. Let's check our flue temperature. So I'm already at 240 degrees. This door can get shut. Once that's shut, you should see a pretty good jump in the temperature. It'll start climbing pretty good. Now, as long as this main red door is open, the flue gas, or the flue fan, exhaust fan, runs at 100%. It kind of teeters. Let's shut the main door. Now that fan just kicks down to 85%. That's like the maximum running speed with the door shut. It only goes to 100% when you open up the main red door here. It's trying to clear the firebox of any gas. So anyway, that's pretty much it. Alright guys, that's the Froling. Please make comments, ask questions. I'll do my best to answer it. If there's something specific you guys want to see, let me know, and I'll include that into the next video with the construction pictures. It'll give me some additional content. But otherwise, I hope you enjoy this. And then I'll show you more once I get my firewood moved. My little lean-to right outside the boiler room here. I finally put up a metal roof and a lean-to, so that way I don't have to mess around with tarps anymore. But yeah, let me know what you guys think. I appreciate the feedback. And take care. Have a good one. Be kind.